Good morning, folks. This is very much intended as a companion video to the main lessons. I'm going to be going through the same things that I did there, but if you want to hear the explanations again, this is the thing to use. It's going to be a little bit more compact and concise, but here we go. So, we're looking at circles today, and essentially we're introducing a formula, or kind of reintroducing. I think this formula was in GCSE Further Maths, and certainly you had just x squared plus y squared equals r squared for circles in regular GCSE. The general idea is if you've got a centre a, b, and a radius r, then you can create this equation here. X minus a squared plus y minus b squared is r squared. So let's actually use that. Here's our first question. Let's try and keep that in shot. So a circle has equation x minus 3 squared plus y plus 4 squared equals 20. We want to find its centre and its radius. So looking at the equation above, it says it's x minus a, so it's clear to me that a equals 3 because we're subtracting 3. And then b, because this is a plus and this is a minus, b is minus 4. So our centre must be 3 minus 4. The radius, well, we can get from here that r squared is 20, but we do need to square root that, which would be, I think, 2 root 5 if we want it to be actually nice. Okay, that's it. Now, you obviously get these questions sometimes to prove that a point is on the circumference of a circle. And remember that you've got an equation for a circle, and if we want to show that a point is on any equation, we just need to show that it works with the equation there. So we're going to substitute in x equals 5 and y equals minus 8 into that equation of the circle, into the x minus 3 squared plus y plus 4 squared equals 20. So let's do that. We need to do 5 minus 3 squared plus minus 8 plus 4 squared, and we need to hopefully get this to be equal to 20. So what would this be? This would be 2 squared plus minus 4 squared, which is 4 plus 16, which is 20. So it does lie on the circumference because it matches the equation that we had. Okay, what about the next one? Where does it cross the x-axis? So if we remember back to before Christmas, x-axis is where y equals 0. So it's a case of substituting that into the equation and trying to find the x-coordinate that goes with it. So we were going to have x minus 3 squared, we don't know what x is, plus 0 plus 4 squared equals 20. And then let's be a little bit smart. So it might be tempting to expand that bracket. I think I can scroll down now. It might be tempting to expand that bracket, but we're actually going to avoid it. We're going to say x minus 3 squared plus 4 squared. So actually, let's go ahead and just call that 16 is equal to 20. We're going to subtract the 16, and then we're going to square root, and then we don't have to expand our brackets. Now you've got to remember, if you do square root, you're going to have a positive square root and a negative square root. So this is plus or minus 2. We can then add the 3 across, and we can say that x is 3 plus or minus 2. So if it was 3 plus 2, it would be 5, and if it was 3 minus 2, it would be 1. So it crosses the x-axis at 5, 0, and at 1, 0. Cool. Let's have a look at another question. So something you're often required to do in this is to use completing the square. So you'll often get given a circle equation like this, where it's in a sort of incomplete form, and we want to find what its centre and its radius is. So this is the process we want to go through. First thing I would do is I would rearrange it so that all of the x's are together, all of the y's are together, and we're going to do 2 completing the squares to put this in the form we want, which is x minus a squared plus y minus b squared equals r squared. So looking at completing the square, however many x we've got, that's our b, we need to halve it and put it inside the bracket. So this is going to be x minus 7 squared, and then we need to subtract that thing squared, so we take away 7 squared. And then we've got y plus 8 squared, and we still ending up subtracting that, so we're going to have minus 64. It's always a take away outside the bracket. That's equal to 12. So we've got x minus 7 squared plus y plus 8 squared. And then we're going to take the 49 and the 64 and we're going to add them across to the other side. So that'll be 76, 125. And that's almost in our equation, isn't it? We want to find the centre and the radius. So we can definitely tell that a is 7, because this is x minus 7. B is minus 8. Remember, we want to change the sign. And then r squared is 125. But we don't want radius squared, we want the radius, so we need to square root that. So r is the square root of 125, which is 5 root 5. So finishing off, we would say centre is 7 minus 8, and the radius is 5 root 5. Okay, then there's a part B which says it crosses a point 4, f, and we want to find the possible values of f. So this is quite similar to what we did on the previous question where it said find where it crosses the y-axis. Except in this case it gives us an x coordinate of 4, we just need to substitute that in. Now we could obviously substitute that into either form of the equation. We could substitute it into the one they initially give us, or into the version that we've worked out. Possibly the smart exam approach is to substitute it into the original form, in case you made a mistake, I suppose, in part A, but I'm going to back myself and use the version that I've worked out. So I know this is x minus 7 squared, so 4 minus 7 squared, y plus 8 squared, so f plus 8 squared is 125, and then we can expand this, so that's minus 3, and if we square it we get 9. And again we're going to do the smart thing and not expand this just yet. That's 125. And we can subtract that, can't we? We can say f plus 8 squared is 116. We can then square root, so f plus 8 is, again, plus or minus if we're square rooting, plus or minus root 116. And so f is equal to minus 8 plus or minus 116. Now, I think root 116 will cancel down a little bit, but it's definitely not one of the nice ones. Let's just have a quick look. Yeah, so we can make that into the very lovely minus 8 plus or minus 2 root 29. Lovely. So we want to find the possible values of f. We've done that. We don't need to write them as coordinates because it doesn't ask for that. Okay. One more question to consider. So we've got a is 4, 7, and b is minus 8, 3. Am I right in saying one more question? I am. AB is a circle diameter. We want to find the equation of the circle. Now, I generally consider it a good idea with circle questions to sketch out the scenario you're being told. We've got our 4, 7 point here, so it's 4 across 7 up, so it's slightly above y equals x, and we've got b is like minus 8, 3. So we've got a over here somewhere, we've got b over here somewhere. We have got what I can only assume is going to be an amazingly drawn circle. Brilliant. And we've got obviously the diameter linking A to B. Now if we think about that diameter, the centre of that diameter is going to be the midpoint of A and B. And if we want to find the equation of a circle, we need two things. We need its centre, so we can do a midpoint for that, and we need its radius, so we can find the length of the line from A to B for that. So let's do that. So to find the midpoint of AB, all we do is we add the 2 points together and we halve it. So we go 4 plus minus 8 over 2 for the x coordinate. That's the x coordinates added together. And we're going to go 7 plus 3 over 2 for our y coordinate. So that's going to be minus 4 over 2. That's going to be minus 2, 5. So that tells us that this coordinate here, this centre, is minus 2, 5. We also want to find the length of AB. In fact, would it make more sense at this point? Yeah, okay, so because all we want is the radius, if we found the length of AB, that would give us the diameter, and then we'd have to halve it. But if we say this is just the centre here, then the radius would just be the distance from A to C. So that was our circle centre, and this is going to be our circle radius. Okay, so AC. So A was 4, 7, wasn't it? Remember, if you want to find the length, you're basically doing Pythagoras. So difference in x plus difference in y, both squared, and then square rooted. So we're going to go 4 take away minus 2 for the difference in x, and 7 take away 5 for the difference in y, both squared. That's going to give us the square root of, so that's 6 squared plus 2 squared. That is 36 plus 4 is 40. So the length of AC is 2 root 10. So that's our radius. And the question says we want to find the circle equation. So let's go back to our thing. So it should look like x minus a all squared plus y minus b all squared equals r squared. That's the format it should look like. We've got our a is minus 2, so this will be x plus 2 squared. That's taken from here. And our b would be 5. So we can say plus y minus 5 squared. And then our radius, well that's r. But we want r squared, and if we square that we'll get 40 because it was the square root of 40. And that's it. That's our circle equation.